You know async and await from Node, so you write Python the same way. This code has 3 problems. It either does nothing, freezes entirely, or runs 3 times slower than it should. The syntax looks identical to Node. That is exactly the trap. Let's fix it and build the instinct for why Python's async is genuinely different. The goal is simple. Fetch 2 URLs, return both results. Node muscle memory writes it like this. It will not do what you expect. Watch. Start at the bottom where we call main. In Node, an async function starts running the instant you call it. It hands back a promise, but the work is already underway because the runtime's event loop is always on, driving it to completion. In Python, calling an async function runs none of its body. It hands you back a coroutine object, a recipe that hasn't started cooking, and then the program simply ends, having done nothing. You'll even get a warning that a coroutine was never awaited. The reason is fundamental. Node has one implicit event loop, always running, baked into the runtime. Python has no loop running by default. You start one explicitly and hand it your entry coroutine using asyncio.run. That one call creates the loop, runs main to completion, and shuts it down. The principle, in Python, nothing async happens until a loop is running, and you are the one who starts it. The intuition. Every async Python program has exactly one asyncio.run at its edge, usually the very last line. If you don't see one, nothing is running. Now the fetch itself. This is the single most common and most damaging async mistake a Node developer makes in Python, and it is completely invisible. Here's the model you need. An event loop runs on one thread. Concurrency comes from tasks voluntarily pausing at every await to let other tasks run. That word, await, is the yield point. It's where a task says, I'm waiting on input-output, use the time for something else. Now, requests.get does real network work, but it is a synchronous blocking function. It does not yield. So when you call it inside an async function, the entire event loop stops dead until that request finishes. Every other task, every other request, frozen. In Node, you can barely do this because the async versions are the default. In Python, the blocking versions sit right next to the async ones and nothing stops you. The fix is a library built for async. Here the HTTPX async client, and you await the call so it actually yields control. The principle, inside async code, every input-output call must be awaitable or it blocks everyone. If a library call isn't awaitable, it doesn't belong on the loop. Push it to a thread with run an executor. The intuition. If you're in an async function and you call something without a wait that touches the network, the disk, or sleeps, stop. You just froze the loop. Last problem, and it's the reason people say async made their code slower. We await the first fetch, then await the second. Read it literally. We completely finish fetching the first URL before we even begin the second. That is sequential. We paid for all the async ceremony and got none of the benefit. It's exactly as slow as plain synchronous code plus overhead. Here's the misconception to kill. Await does not mean run this in the background. Await means pause right here until this one finishes. To actually run things at the same time, you launch them all first, then wait for the whole group. That's what asyncio.gather does. You hand it several coroutines, it schedules them onto the loop together, and while one is paused on input-output, the others make progress. 2 requests that each take 1 second now finish in about 1 second, not 2. In modern Python, you'd often reach for a task group, which does the same thing with cleaner error handling. The principle, awaiting in sequence, is serial. To go concurrent, start everything, then gather. The intuition, 2 awaits back-to-back on independent work, is a bug. That's a gather. Here's the payoff on a timeline. Awaiting one fetch, then the other, runs them back-to-back, 2 seconds. Gather starts both at once, so while one waits on the network, the other is already working. Same 2 requests, but about 1 second. That's the whole point of async, and it only happens when you launch them together. Same 3 lines of intent, now correct. There is a loop, started explicitly. The input-output actually yields, so the loop stays free. And the 2 fetches run together, not one after the other. It went from silently doing nothing to genuinely concurrent. And now you can see why each change was necessary, not just what to type. The tell was never the syntax. Async and await look identical to Node. The tell is the model underneath, an explicit, single-threaded loop that only makes progress when your code yields at an await. Hold that one picture, and every one of these mistakes becomes obvious before you make it. Subscribe to Codecraft. Next, we rewire how you think about types.